All right, so back to more twin. What is it, Wednesday morning? Start off with number 8. I think I've done through 7 so far. So start off with number 8. Oh, wow, it's one of those. This is one of those that everybody should get right. Everyone should get right. Everybody should get this question right. Will it happen? No, but you should. Your potential zeros are found by finding factors of the constant, which is this guy right here, that's your constant, over factors of A. You know, A is the first letter in the alphabet. A is legit the first number you see. So that's it. So we're doing factors of 4 over factors of 9. If you completely factor 4 in order, and you talk about all its factors of 4, you'd have plus or minus 1, plus or minus 2, plus or minus 4. It's not a big list. Factors of 9, plus or minus 1, plus or minus 3, plus or minus 9. Will everybody get this one right? No. Some of y'all are too medicated to get this right. So the first thing you do is you go through and you divide each of the top factors by a 1. So here's my list. Plus or minus 1, plus or minus 2, plus or minus 4. And I'm done with the 1. The next thing I do is I go through and I divide by 3. Whoops, sorry, you couldn't see my list. I went through and I divided every single thing by 1. Done with the 1, moving to the 3. Plus or minus a third, plus or minus 2/3, plus or minus 4/3. And I'm done with the 3. So now I move on to the 9. Plus or minus 1/9, plus or minus 2/9, and plus or minus 4/9. That ought to be an easy 5 points or whatever I make it worth. It ought to be easy. One would hope, right? We'll see. This is actually a really easy test. It really is a pretty simple test. I thought it was. You can make sure I'm actually recording. Rolling. It is first thing in the morning. All right, cool. All right, find all the zeros of x cubed. Something's missing there. Is it a plus or a minus? I guess we'll find out. Find all the zeros of this function. So apparently I left the sign off. I must have edited this. Let's see if it's a positive. I can figure it out real quick by looking at the graph. I most likely intended there to be 1 0. I'm pretty sure it's positive. We'll find out. Yeah, I definitely intended for that to be a plus symbol. Definitely intended that. So, anyways, find all the zeros. If you look at the graph, there's one real one. It's right here. All right. The known zero is x equals -2, because that's where x is -2. You can also look at the table. Do you see how y is 0, x is -2? Tables are important. Tables help kids establish and connect dots and make relationships. Anyways, a known zero is -2. So now I'll do a little synthetic division. Synthetically divide out a -2, throw in my coefficients. 1, +2, 9, and 18. And, I don't know why we're not getting this. It's not a hard thing to do. I mean, if you pass 5th grade math, you could do long division algorithm, which is way more complex than this. This is simple. We drop, we multiply, because -2 times 1 is -2. We add, and we just repeat this multiplication addition step over and over and over. -2 times 0 is 0. 9 plus 0 is 9. -2 times 9 is -18. And surprise, there's a 0. And for, I don't know, the 10th time with y'all this year, remainder constant xx squared. Cool. All right. There's two ways of solving what's left. We have x squared plus 0x plus 9 is 0. And again, there's two ways of doing this. Some kids are going to just hit it with the quadratic formula. They get comfortable with the quadratic formula, so you could do the quadratic formula. Opposite b, well, that would be 0. Plus or minus square root of b squared, and b is 0. A is 1, b is 0, c is 9. Minus 4 times a, which is 1, times c, which is 9. Both pieces sitting over twice a. So we end up with x is 0 plus or minus the root of, I believe, negative 36 over 2. No. The root of negative 36 is something you're supposed to know. It's imaginary. X is 0 plus or minus the imaginary root of 36 over 2. I don't even know why I'm writing 0 anymore. Don't need it. And then the root of 36 would be 6. So 6i over 2 plus or minus 3i. That's probably the longest way to do this one. It actually doesn't make sense on that one to use the quadratic formula, but there were my three zeros. Negative 2 and then plus or minus 3i. The truth is, if you would have just wrote x squared plus 9 is 0, which is what you had over here, moved your 9 over, counteracted squaring by square rooting, realized it was the imaginary root of 9, you would have gotten plus or minus 3i right off the bat. Now, a lot of issues we run into here is y'all don't want to write. You think you're too good to write. If you think you're too good to write, I'll see you next year. You need to learn how to write. Even if your handwriting is horrible. God, the number of kids I've seen in my career that say, I don't do math by writing. They all make F's. Every one of them fails. You don't do math at all when you don't write. Polynomial has 4 known zeros, negative 1, 5, root 2 minus 1, and 5 minus 3i. What are the remaining two zeros? So what we're going to do is we're going to apply the conjugate theorem. And the conjugate theorem is pretty simple. It says weird zeros have conjugates. So the conjugate of root 2 minus 1 happens when you change the sign of the weird thing, not the cool thing, not the negative 1. Conjugate of root 2 minus 1 is negative root 2 minus 1. That's a zero that you can figure out. The conjugate of 5 minus 3i, the only weird thing in there is the imaginary number. Conjugate of 5 minus 3i is 5 plus 3i. Then I talk about the degree of the polynomial. Well, we had 4 zeros here, 1, 2, 3, 4, and then we found 2 more, 5, 6. We have 6 zeros, which means, according to the fundamental theorem of algebra, we are x to the 6th power. That's all it means. It's a 6-degree polynomial. It's x to the 6th, or n to the 6th, whatever. It's just something to the 6th power. What was the relationship between those two given zeros and their counterparts? They were conjugates. I even have that as a small bonus. It's easy, conjugates. Number 11, the question that no one should miss, but again, people will miss. I don't know why. Again, I just assume you're well medicated. How many zeros, real or imaginary, is a polynomial 5x to the 108th power? And then who cares about the rest of it? Doesn't matter in the context of this question. This is what matters. Whatever the leading exponent is, that's your answer. It has 108 zeros, real or imaginary. Number 12, determine the power function zeros, including multiplicity of f of x is 4x squared times x minus 1 cubed times x plus 2 times 2x minus 1 to the 4th times x squared plus 1 squared. The power function. Power function, which we haven't talked about in class yet, we may not talk about it till Thursday, happens, it would be the leading term in standard form. If you don't know what standard form is by this point in time, there's not much I can do for you. We don't actually have to write this thing out in standard form. We're going to do a whole bunch of near math. Okay? It's not algebraically correct. I'm going to grab what x would be from each of these factors. So the first factor is 4x squared. The second one, if I wrote this thing out twice, I would have x cubed plus a bunch of stuff. I hope you get that. I'd have to FOIL and double distribute, but I would get an x cubed. All right, so 4x squared times x cubed. This one is just going to generate an x. This one is going to generate a 2x to the fourth. Just going to take that 2x, raise it to the fourth power. This one is going to generate an x squared squared. Again, I don't have to put the thing in standard form, but I do have to figure out what this is going to be. Now, your test won't be this bad. This is a twin. They're supposed to be a little bit harder. Let's see here. 2x to the fourth is 16x to the fourth. Because 2 times 2 times 2, I think times 2 again is 16. And this guy becomes x to the fourth. So let's see what I have. I have x squared times x cubed, that's x to the fifth, times x, which is x to the sixth, times x to the fourth, which is x to the 10th, times x to the fourth, which is x to the 14th. And then my coefficients were 4 and 16, 64. That's the power function. That determines end behavior. That tells me this thing opens high and ends high. It's positive, even exponent. Anyways, 64x to the 14th. And you're supposed to find all the zeros, talk about their multiplicity, decide if they're a cross, a touch, or imaginary. So crosses have odd multiplicity. If you don't know what an odd number is, either get off the drugs or on them. Touches have even. I talk a lot of crap. Here I am having a hard time spelling. Have even multiplicity. And of course, imaginary things are imaginary. Happens when you take the root of a negative. So the first zero happens right here, 4x squared. We say 4x squared is 0. Well, x is 0. The exponent tells me my multiplicity. 2 is even. That is a touch. Okay? My second zero happens at this factor. X minus 1 is 0, so x is 1. The multiplicity is the exponent of 3. I don't know why I wrote m for multiplicity. It was 2. The multiplicity is 3 because that factor has an exponent of 3. And that's a touch because it's odd. The third zero happens at 2x minus 1 to the fourth. I'm just going to talk about its multiplicity first. It has a multiplicity of 4, and 4 is even. Man, here I am talking crap. 3 is odd, that's a crossing. 4 is even, that's a touch. Now back to the factor. 2x minus 1 is 0, x is a half. Okay. Next factor is x squared plus 1 squared. Funky. Actually, I have one extra place in here that I don't need. But it's x squared plus 1 squared. So x squared plus 1 is 0. X squared is negative 1. X is plus or minus I, because I is defined to be the square root of negative 1. So 0,4 is I, and 0,5 is negative I. Okay, one of them's I, and the other one's negative I. They're conjugates, they always happen together. Each of these has a multiplicity of 2. Because they're imaginary, they're not going to cross or touch the x-axis. They're both imaginary. And I have no idea why this line is here. I guess I just thought I needed it. That should be it for that one. It's not that bad. 13, the graph of a polynomial has 129 turning points. What is the least degree the polynomial could be? So these are also probably from the notes that we do Thursday. It says, and it's called turning point theorem, the degree of a polynomial is at least one more than the number of turning points. It's just a theorem. Okay? It's at least one more. So the degree here is 129 plus 1, which is 130. That's one of those easy problems that everybody should get. Everybody won't, but everybody should. All right, below is the graph of f of x. Write the equation of f of x in factored form. I'm not even asking you to put it in STD form. And don't forget about a. So a is the very first thing to actually write. F of x is a. We're going to start writing our factors out. I got 1, 2, 3, 4 zeros, so I need 4 factors. Maybe. That one's kind of interesting, but we'll go ahead and write it out as parentheses and then we'll clean it up. I'm actually going to start with this one. That one right there. That's x equals 0. The factor that creates it is x minus 0, which becomes just x. Okay? That's what it becomes. X minus 0 is still 0. This one, this is x equals negative 3. The factor that creates it is x plus 3. This is x equals negative 1. The factor that creates it is x plus 1. Okay, this is easy so far. This is x equals 2. The factor that creates it is x minus 2. Now, I have to go through and I have to look for crosses and touches. Okay? Touches happen at least twice. The only touch that I see is right here. And that was created by this initial factor that I wrote. So I don't like the fact that I left x in parentheses. That x is just squared. And then I just write down the rest of the factors. They're all crosses. Cross the x-axis, cross the x-axis, cross the x-axis. They only have to happen once because we're writing a polynomial of least degree. And there's what I have. That was easy. The hard part's actually finding a. And phooey, Milbrath didn't give you enough information to find a. I should have plotted a point for you. I didn't. You'll have this on your quiz. On your quiz, there will be one extra point plotted. I just forgot to do it. I don't know why I didn't. But there's a good point right there. This is 1, 4. That's what I'm going to use. So I'm going to use the point 1, 4. Everywhere I see an x, I'm a 1. Everywhere I see a y, I'm a 4. So 4 is a times a 1 squared times a 1 plus a 3 times a 1 plus a 1 times a 1 minus a 2. All right. Crank out the math. This is a 1. This is a 4. This is a 2. This is a negative 1. I like what I'm seeing because it's negative. I do like what I'm seeing here. Yeah, I expect it to actually be negative. What do we have here? We have negative 8. 4 is negative 8a, so a is negative 1/2. So my polynomial in its full, beautiful factored form is f of x is negative 1/2 of an x that is squared times x plus 3 times x plus 1 times x minus 2. Now, I mentioned I like the fact that this is negative. If I do some near math here, x squared times x is x cubed times x is x to the 4th times x is x to the 5th. The power function is negative 1/2 x to the 5th, which is supposed to start its day high and end its day low, which you can kind of tell that's what the graph is doing. It's just a way of checking or eliminating choices. So there's 7 through 14. I need to go make sure I get some stuff printed before classes start. I may finish this video today. I don't know.